everybody. Thank you so much for inviting me, Zeiss and the organizers. So you know my name, you know that I built Cycle.js. I've also been working with RxJS, and I've been working on RxJS. Raise your hand if you've ever heard of RxJS. That's a kind of good number. So this talk was labeled JavaScript, and we're going to be talking about JavaScript. But actually, most of the stuff we're going to see today are like Kotlin, Haskell, Java, Aspect-J, and even some Microsoft Excel. So it's like truly polyglot presentation. So to get started, there's this buzzword which is reactive, right? And we've been talking about that like a lot of, it's kind of like a cool thing. If something is reactive, it's kind of cool. But like, what does it actually mean? It's kind of confusing. So if you open Wikipedia, for instance, you're going to see automatic propagation of change or dynamic data flow. I mean, what does that even mean? Because like, data is always flowing from A to B in any program, and it's dynamic, so any program is reactive. I don't know. So what do you think? And this is actually a question. What do you think is reactive? Does anyone want to give like my gut feeling definition? Yeah. Okay, it's like in Excel, you change something and the whole thing changes. Okay, that's good. I mean, that's good, you're getting there, but it's complicated, you know? It's like, how can you say that a program is not reactive because, well, I changed something and something changes, so I don't know. It's kind of complicated. But what I want with today is that you leave here to the coffee break knowing what reactive means and knowing how to classify that this is not reactive, and especially why do reactive? And why is this stuff important? Let's talk about large code bases for a little bit. So they all end up complex a bit like this, so it becomes spaghetti, and each of those boxes is like a class in your Java code base. Why can't we just keep it simple? I mean, it's annoying. So the reason why it becomes complex is there's two types of complexities. Accidental complexity, it's whenever you over-engineer or you have too much stuff and you need to delete some nonsense. And it basically happens every time you use Java. So yeah, really, I mean, don't be offended if you do Java. I've been doing a lot of Java, and like for work and for my master's thesis, and it really is really bad. And the other type of complexity is essential complexity. It basically means that it's already complex no matter what language you're going to use. And here's an example in e-commerce. You have all of those concepts, and they have to be related to each other. There's nothing you can do to simplify that. It's just going to be like that. And probably there's even more concepts. So imagine that each of these boxes would be a module. Depending on your language, it could be a class or a file or, I don't know, a module. And an arrow means that, you know, this will change that. For instance, you know, the payment will somehow change the sale, and, you know, the user profile will affect the invoice. So if we have, let's say, an arrow from the cart to the invoice, it means that, you know, somehow the cart will change the invoice. As an example, let's say you add a new product to the cart, and then you need to update the total amount invoiced, right? Now, because you're programming in modules, so everything lives inside a module, okay? Everything lives inside a file or inside a class. So that means that the arrow also lives inside a module. But where does it live? Well, it can either live in the arrow tail, like that, or in the arrow head. So if it lives in the arrow tail, it means that inside the cart module, you have some kind of code that says, update the invoice. Or basically, you know, when you're going to add a product, we're going to call invoice.update, okay? So if we look at a bit of this code in Kotlin, which is similar to Java, we have there import the invoice singleton, define this other cart singleton, and then we have a method or a function that when we add a product, we're going to call invoice singleton update the invoicing total. So in this situation, the cart module is kind of proactive. You know, it's responsible for making that change happen. And the invoice is just sitting there passively, doing nothing, and it has this method there, so you can poke it and say, you know, update. So the invoice is completely unaware that it has that dependency with the cart, right? It just exposes this method, and anyone can call it. So that means that we need to have the increment counter public in order for other modules to change it. And we're going to call that passive programming. It's characterized by remote imperative changes and this sort of delegation of responsibility, because the invoice is not responsible for itself. But we can define the arrow in the arrowhead like that, which means that the invoice would have some code that knows how to register a callback in order to run that function whenever a product is added on the cart, right? Now that's different because now the invoice module will import the cart. So before we had the cart importing the invoice, now we have the opposite. And there inside the invoice singleton, we have this setup method that will add a callback there to the cart, and then the invoice knows how to update itself, okay? So we put all this logic there. So now the cart assumes this like broadcasting role. The only thing it needs to do is the cart does its own cart stuff, and it sends out some events about some stuff that happened inside it. And then the invoice just assumes a reactive role where it listens to those interesting events happening in the cart, and it changes itself, okay? So, yeah. And for that, we need to make these events public on the cart module, because then any other module can listen to those. And voila, this is called reactive programming, okay? Easy definition, no longer a buzzword, is that it's whenever the module being changed is responsible for defining that change, okay? It's not it's not the cart that's defining that change at all. So this is definitely not new, okay? Callbacks are reactive. There you go. Callbacks are cool. Maybe. But, you know, next time you argue with your coworker, you can say, you know, callbacks are reactive. And you can actually define why. So to summarize, passive programming is whenever you have remote setting, remote updating. And reactive programming is whenever you have self-updates according to these events. And in both of these cases, something needs to be public. So it's not like one of them completely wins the other. They're dual to each other. And it turns out that a lot of stuff are reactive. I said callbacks, but also spreadsheets are reactive. If you even check in Wikipedia, they talk about reactive programming there. And just like our friend above there said that, you know, it's something that behaves like a spreadsheet. And why is because if you look at A and B, B is basically A times 2 divided by 100. And where's that relationship defined is in the formula for B, okay? So there we go. Because if you think of an arrow from A to B, that arrow is defined on B. That's how it's reactive. Okay, so back to the real world e-commerce example. Let's say you're working with a system like this and it has 70 classes or files. And you want to understand how does this one module, you know, I want to understand this module, okay? You usually have two questions in your mind. One of them is, how does this module work and how does this module, what does it affect in the rest of my system, okay? So let's suppose you have passive everywhere. This is usually the case with a naive Java code base, is that every class is updating the other classes, okay? If you ask yourself, which other modules does the invoice change? Okay, no one wants to give a guess, but it's sale and payment, of course, because we have those arrows there. And how did we discover that? Is by looking inside the invoice module. Then we see, okay, it calls sale.update, it calls payment.update. But if you ask yourself, how does the invoice module work, right? How does it change over time, that type of stuff? You need to find all the usages of its methods. You need to, you know, it just exposes public methods and you need to hunt down, grep around the code base. How does the rest of the code base call these? But now suppose that you have reactive everywhere, okay? You're doing like spreadsheet type of stuff everywhere. And you ask, what other modules does the invoice change? Then it's the same answer, sale and payment, but the way that you discover that is by searching for the usages of those events that the invoice has, okay? The invoice emits some events, some other folks listen to those, so we need to search for all of those usages of events. But if you ask yourself, how does the invoice work? Then you only need to look inside the invoice module. And then you're going to see, okay, the invoice imports the cart and it uses it like that, and it imports the coupon and it changes itself according to that. So passive and reactive are dual to each other in this regard. Okay, in both cases, you have some use case where you need to find usages, some use case where you need to look inside. So can we say that one is better than the others? They look so balanced, you know. But the thing is that you usually want to know first, how does this module work? And then once you know how it works, you can answer, okay, what are the other things that it affects? And that's why reactive programming matters, and it's a good default because it allows you to just look at something and, okay, you understand it. And that's it. So in contrast, if you would use passive by default, okay, passive everywhere, then you basically get modules that are irresponsible because you want to know, how does the invoice work? I don't know. You need to start searching for logic that is scattered all around the code base in other modules. So if you've ever been in this hell of like, find usages of this, find usages of that, find usages of that, and then you're like, okay, what was I looking in the first place? And you're trying to build this mental model of how stuff work, you're just visiting the whole thing. That's what I'm talking about. And here's an example that I've done a couple of times and it's proven really well, to work really well, is analytics. How do you set those events up? Usually what I've seen as in like a naive case is that, let's say we have a login page and inside that we have a piece of code that says analytics.sendEvent. And the front page says analytics.sendEvent. And then you want to know, okay, so how does analytics work in this application? You don't know. You open the analytics module and the only thing you see is send event method. Okay, and then you need to search for everywhere else that has that. But if you do reactive everywhere, then it sort of liberates all of these pages from knowing anything about analytics. And then if you want to know how analytics works, you just open the analytics class or file and it's all there. And I've done this for real in like an Android and Java application. That's been like super nice. So, and I really recommend it. So right now, if this may be sounding like aspect-oriented programming, has anyone heard of that before? Yeah, it's kind of like an oldish type of thing. It's meant for cross-cutting concerns, like things that are everywhere, like logging or analytics. And here we were able to solve a cross-cutting concern with reactive programming. I don't want to go too deep into aspect-oriented programming, but here's just a dumb example really quickly. Let's say you have a login page, and right now it has nothing related to analytics. That's good. It's only doing its login stuff. And with a framework called AspectJ for Java, you can do stuff like defining a point cut, which is basically defined moments in the execution of your program. Like, for instance, the login page was initialized. I'm going to call that opened. And then you can define an advice that is code to be run whenever the execution passes those points. It's basically saying, you know, after the execution of the program hits opened, run that advice snippet. So with that, we're able to isolate all of this analytic stuff in these advices, basically. And we can do something similar with reactive programming, but in this case, we need to add a little bit of stuff, which is the broadcast event. So by the end of the initializing method, we need to say, okay, broadcast this event called opened. And so far, there's nothing related to analytics itself. It's just an event that other modules could use in completely different ways. And then it should be able to be possible to listen to that event. So for instance, here I can make the analytics class that will import the login page, and then it knows how to set up a listener to, you know, whenever opened happens, I'm going to send this event. What do you get is that if you want to know how does analytics work in my program, you open this class or this file, and you see everything. Also, if you want to turn off analytics everywhere, you can just remove this class, or you can just swap it with something else. That's really nice, right? Because we separated the whole analytics concerns in one place. That's nice, but if you're a nitpicker like me, then you're seeing problems. And one of the problems is that I'm not really being honest here because it's not really reactive everywhere. There's still some passive programming here. For instance, back in the e-commerce example, which is basically the same thing, there we had this remote update. So what is really going on here? Because I have a remote update, right? The thing is, it looks reactive, okay? The invoice is reacting to the cart. It is. But when you look deeper, inside the invoice, it's just the setup phase that's reacting to the cart, but inside that class, I'm still updating some other part, let's say some member of that class, right? So how could we not have setter or updaters at all? How could we just use reactive everywhere? And there we go, our friend at the top guessed correctly that something like a spreadsheet, right? There are no update methods in spreadsheets. And that's why, business guys love this, because the only thing that they have is data and formulas. So let's stop and admire Excel a bit. Yeah, so anyway, and we can model something like the e-commerce application, because you have there a cell for the invoice, and what it does, it just has a formula saying, I'm going to sum over the column of products. There we go. We don't have any updates whatsoever here. So if we would plot that as a timeline, okay, then every time we interact with that column of products and we add a new product, it's going to automatically recalculate the invoice using the sum formula, and so forth, every time something is added. So, but what if we could have more formulas than just sum and average and all those statistic stuff that Excel has? What if you would have in Excel like delay? If you would have delay, then it means that you change a cell here, and after 1 second, another cell changes here. And with that, you suddenly enable animations in spreadsheets. I don't have a demo of that. But just imagine in your mind that you change a cell there and then everything kind of goes funny and stuff. But if you would add not just delay but a ton of other crazy stuff, then you end up with something like a functional and reactive programming library like RxJava or RxJS. And the idea here is basically to represent each variable as a stream of values over time, and in RxJS and Java they call this observables. So if these would be primitives, okay? I have a stream here, and I could just pass it around, like I could give it to this module, and then that module would have a stream. It can listen to that stream, and it can do stuff. That's the idea. You can just pass around streams as if they would be like integers or whatever. So whenever I say stream, try to put in your head that it's kind of like a spreadsheet cell or a spreadsheet column with superpowers, in case you get confused a bit. Or you can think of it as just a stream. So how can we get rid of passive programming here with this update thingy? We can just think, every time I add a product to this cart, that's an event, right? I added a product, so that's an event. And if you just put them all in a timeline, that's a stream of events. And then I could use that stream of events and I just do a sum over all of those, right? Kind of like in spreadsheets. And that's what we're going to do here. So let's imagine that the cart would have a stream of product added stream. And then it passes, we give that to the invoice, and then the invoice knows, okay, I'm going to add over these with the fold. And then we get out a stream of values of that invoice total calculated. That's why it's a float there. That's really nice because then if you want to know how does the invoice work, okay? You don't need to hunt down any update invoice method at all. Even internally here, we don't have any update at all. We can just look inside that get invoice. And we know exactly how this thing will behave over time. Just like in a spreadsheet where you have a formula there and you don't need to hunt down any other kind of update method. It's not passive anymore, but if you're a nitpicker like me, you probably see a problem. Anyone see like a really weird problem? Okay, well maybe this has been kind of hidden. Okay, yeah. Gets are not like updates or setters, so that's not passive, but yeah. Okay.
Isn't the result of, so we are not just taking this observable and creating some, this component, this part of the state, is that the result
Yeah. Okay, we're kind of short in time, so we need to go like chop, chop, chop. So what you're saying is that it's kind of like a callback still? I agree. Yeah, it's kind of composing callbacks. But the problem that you haven't seen is that there's singletons everywhere. Oh my God. What are we doing, you know? Here we have import the cart singleton, and we have defining the singleton invoice. And, you know, singletons are not good. If we do reactive everywhere, we get singletons everywhere. And if we do passive everywhere, we get irresponsible modules. And, you know, with singletons, you really don't have reusable code because it's statically importing some specific thing. And it turns out that while we were doing reactive everywhere, we missed out on something nice about passive programming. Is that it's really good for data structures, whether it's mutable or immutable. For instance, list.sort is a passive programming thing because, you know, the list is just sitting there waiting, and then you can just kick it, say sort, and then it sorts itself. Yeah, and it's also really good for dependency injection because you can say, yo, depend on this, and then it depends on that. So, yeah. And then when you're dealing with dependencies, there's two things, okay? It's like, what is exactly the thing that I'm depending on, and how do I depend on that? We don't need to put those two things as one. We can separate them. So here we had import the singleton, the card singleton, and that's exactly what am I depending on. And the how do I depend on that is here this observable declaration. I'm saying, given that stream of product adders, I'm going to depend on it like this. And this is the bad part. We want to get rid of this. So the good part of passive programming is that the invoice was unaware of the dependency, right? It's a nice thing. But the good thing of the reactive programming is that the invoice was responsible for changing itself. So could we have these two things? Yeah, we can with passively reactive. I'm not joking. It's like you can actually use reactive just to have this property of how does it work, look inside, and passive to know, you know, I don't know who I depend on, please inject. So let's change this code. The way that we do that is remove these singletons. They're not singletons anymore. Now this is like a invoice class. And then we add this member there, public var cart, and it's public, so anyone can set that, right? That's passive programming. And then I'm using this .cart product added observable. Okay, so someone can set that cart for me, and I'm going to depend on it like that, passive style. So this is good because how does the invoice work? Just look inside the getter. What does it depend on? It's reusable, anything. But if you're a nitpicker like me, you probably notice some problems here. This is not perfect because, you know, I have just get invoice inside an invoice class. So can we do better? One thing we can do is we can get this cart member and put it in the parameter of the getter, like that, okay? Because, you know, functions already have a dependency injection mechanism. It's the parameter, okay? You just pass that parameter, the parameter is the dependency. There you go. And why do we have this class? I mean, just go away, you know? So in Kotlin, you can do this, and that's really good. That's why Kotlin is good, Java's bad, because in Java, you would have to have a class. It doesn't matter. So, and do we even need the cart? We only need the product added observable, right? And it happens to be on the cart, but we can just make that be the argument. So given the product added stream, we're going to depend on it like this. We're going to sum over all the stuff, and we're going to spit out the stream of invoice values. And there we go. Now we get a function that only takes an observable stream of product added, and then we get out an observable stream of calculated invoice. Basically this situation here. Stream, stream, stream. And the function is a dependency injection mechanism, probably better than, you know, setting things like in class members. And because it's a function, we also have the opportunity of making it a pure function. And we just need to make sure we're not doing side effects. Okay, what's the problem with side effects? Here's the problem. If I pass foo to this function, I want to get out A. And then I pass foo, I want to get A again. And then I pass foo again, I get B. And that's not nice because, you know, how can we predict what this thing is doing? So that's why moving side effects away gives us this predictability. So we can move these side effects by putting them in listeners or observers. Basically, I have the stream, I pass you the stream, and then you can listen to it and do some nasty stuff like analytics.sendEvent. And that is a write effect, okay? I'm sending stuff to the server, that's a write effect. But there are other types of effects that we need to take care of. One of them is reading, right? The opposite of writing. For instance, every time the user clicks on buy this product, buy, that is a click, right? And that comes from the user. We're reading that from the external world. We can model that as a stream of clicks. And if we keep on doing this, we end up with an architecture like this that has only streams and functions, where all the side effects are pushed to the extremes, where we start with like read, we process stuff, and we end up with writes. And on the left, we have pure logic, and on the right, we have only effects and handling. And everything on the left was completely reactive, like spreadsheets, and also completely functional, because we don't have side effects. And voila, there you go. This is the idea in Cycle.js. So yeah. And it's a framework for JavaScript. You can check it out. Let's look at a little bit of Cycle.js, okay? Now you should know everything of Cycle.js. Oh no, sorry, okay. Yeah, so the way that we do Cycle.js is that all the pure logic that I talked about goes in this main function. Sources are basically everything that you can read from, like clicks, and sinks are everything that you're going to write. So for instance, here we can detect clicks on some kind of button, and that is a stream. And then we use formulas like in spreadsheets to make, we sum all of those clicks over time, kind of like you have sum in spreadsheets. Then we map that to a markup, okay? And this markup will be the write effect. I want to write this to the DOM, and I want to read clicks from the DOM. And this is the application running in the browser, and on the right we have a dev tool that visualizes the streams and the functions between those. So at the top we have a read stream, okay? Clicks are at the top. And at the bottom is the write effects. So basically the bottom square there encodes basically how to make this markup appear on the DOM. And the events passing through are this data flow network, It turns out that this is not a new idea. It's basically the same as an ancient Haskell I/O model called stream I/O. It's also the so-called data flow paradigm that exists since the 60s or 70s. And it's pretty much explored a lot in visual programming. So in some game engines, they use visual programming with data flow and stuff like that. And yeah, it has a lot of connection with other good sort of existing literature. So to summarize, this is what I want you to take home. Reactive programming is self-updates according to events. And passive programming is remote setting. Why reactive? Is because you want to be able to look inside this module and know how it works, right? It's a good default. And if you start moving effects to the edges of your system, you end up with functional programming in some form. And it's a great idea that brings separation of concerns and predictable code. Thank you very much for listening.
Hi, thank you for a very clear and accessible talk. I think you've made a lot of stuff clear. Now, I noticed that fans of reactive programming, they like to discuss continuous versus discrete reactive programming. And I have to say, I never fully understood it.
Yeah.
Does it matter? And if so, can you give the very short version of what the distinction is?
Yeah, so it really matters a lot. And in this presentation, I didn't try to go into that. But a really good example of that is your age and your birthdays. So your age is a continuous value. You always have an age. Right now you have an age. But you don't have a birthday right now. I mean, birthdays are events that happen annually, right? But these two are really interrelated. Every year your age changes because of your birthday. So they are like core ideas that you want to express sometimes. Some things are fundamentally event streams, and some things are fundamentally values over time, like ages and birthdays. And they happen all over the place in anything, you know.
Okay. Is this library using reactive-x?
Yes, CycleJS is using reactive-x. And
Sweet.
yeah.
Thanks.
And we actually support multiple stream libraries since Monday. And yeah, since Monday, seriously. So now we have our own stream library called Extreme, because I always wanted to do extreme programming, but I never knew how to do it. And so, yeah. It's, yeah, reactive-x.
Okay, thank you, Andre. Great talk.